Particle P leaves a point A at time t equals 0 seconds and moves in a straight line with the acceleration given by this expression here. The particle P has an initial velocity of -3 meters per second, and point A has a displacement of 4 meters from the origin. Calculate the initial acceleration of P. Well, that's just A of 0. So that's going to be 16 divided by 1 cubed, which is just 16 meters per second squared. Is P ever stationary? If your answer is yes, determine the times when this happens. If your answer is no, explain why. So we want velocity now. So to get velocity, we're going to integrate acceleration. Remember, you can do this on the calculator. So that's 16 2t plus 1 to the -3 dt. So that's going to be 16 2t plus 1 to the -2 divide by the new power and by the differential of the inside function and add a constant. So 16 divided by -4 is -4, so it's going to be -4 over 2t plus 1 squared plus a constant. Initial velocity is -3, so -3 is going to be -4 plus c, giving us c is equal to 1. So that gives us that v is 1, take away 4 over 2t plus 1 all squared. So we're interested in if v is equal to 0. So why don't we just solve on the calculator? So we're going to solve 1 take away 4 over, I'm just going to use x, 2x plus 1 squared equals 0. And it gives me x is -1.5, so t is equal to -1.5, or t equals 0.5. Not possible. So yes, it is stationary once when t equals 0.5. Calculate the displacement of P when t is 12 seconds. Once again, you can do the integration on your calculator. So let's call that x, and that's going to be the integral of 1 take away 4 2t plus 1 to the -2 dt. So that's going to be t take away 4 2t plus 1 to the -1 divide by the new power and the differential of the inside. So that's going to be t plus 2 over 2t plus 1 plus a constant. Now back here we're told that x is 4 when t is 0. So 4 is going to be 0 plus 2 plus c, which means c is equal to 2. So x is going to be 2t plus 2 over 2t plus 1 plus 2. So x of 12 is going to be 12 plus 2 over 25 plus 2, which is 14.08 meters. Calculate the change of displacement of p during the third second. Now, the third second goes from t equals 2 to t equals 3. So what we're looking at here is x of 3 take away x of 2. So that's going to be, remember the expression is just here, t plus 2 over t plus 1. So we know that x of t is t plus 2 over 2t plus 1 plus 2. So that's going to be 3 add 2 over 7 plus 2, take away 2 plus 2 over 5 plus 2. That gives us 0.886. And that's correct to 3 decimal places. Determine the maximum speed of p during the first 3 seconds and the time when this occurs. There's all sorts of ways we could do this. Remember, we've got the calculator available. So v is 1 take away 4 over 2t plus 1 all squared. And the first 3 seconds means from t equals 0 to t equals 3. I might just graph this. So graph and table, let's just clear anything we've got there. And so we've got 1 take away 4 over 2x plus 1 squared. So let's just graph that. Now we're only interested between 0 and 3, so I might just go from, say, negative 0.5 up to 3.5, and I can see the y's, there wasn't much of that, so let's go negative 1 to maybe 6 or something like that, and then we get a good picture of it here. So it's speed that we're after, so what we're going to be interested in, I can see there's no turning points along here. In fact, we can see that if we just look for a maximum. Not found. So it's going to be the end points that we're interested in. So it looks like I need to actually bring the graph up a little bit like that. So we're going to be interested in v of 0. So v of 0 is going to be, you could easily substitute into the formula, but let's just carry on. Let's do ycal when x is 0. That gives us negative 3. And then do v of 3. So analysis, gsolve, we'll do a ycal when x is 3. And that gives us 0.92. So clearly the maximum is this, because they're asking for speed. So we're going to say max speed is equal to 3 meters per second. Calculate the total distance travelled by p during the first 3 seconds, and remember from our earlier work and from what we can see on the graph here that it's going to change direction at 0.5. So we can get around that by doing the integral from 0 to 3 of the modulus of v dt. So let's go to main. I'm just going to clear everything else up. And we know that we can find integrals in Math 2. So we're going to go from 0 up to 3. Then in here we need a modulus function. And the v was 1 take away 4 over 2x plus 1, and that's squared. And we're doing that with respect to x, and that gives me 2.29, correct to 2 decimal places.